Namaskaram. In this session, we will discuss the transition matrix between two bases of a vector space. Okay, consider two bases for R square. We have seen that these two are bases. Okay. Okay. Also, it is clear that the coordinate of this vector v with respect to the basis b is the matrix 3, 2. And similarly, you can find the coordinate of v with respect to the second basis equal to 5 by 2 and minus 1 by 2. That means we can write this 3 by 2 as 5 by 2 times first vector minus 1 by 2 times second vector. It's the meaning of the coordinate. Okay. Okay. Here actually these two coordinates are they are the coordinates of same vector v. Here v remains same. V is 3, 2. Right. Only the bases are different. So corresponding to different bases, the coordinates are different for a same vector. So naturally, we expect a relation between these two matrices. So this is our natural question. Does there exist a relation between these two matrices? Okay. Answer is yes. The relation is given by this result. Okay. The result says that if b equal to u1 u2 extra un and c is equal to v1 v2 extra vn are two bases for a vector space v. So we consider an n-dimensional vector space v, and we consider also two bases b and c. Okay, b contains u1 to un and c contains v1 to vn. Then we choose an arbitrary vector v from capital V. Then we know with respect to basis b, this v has a coordinate. We denote it by matrix of v with respect to b. Similarly, with respect to this basis, v has another coordinate. We denote it by v with respect to c. So our question, does there exist a relation between these two? Okay, this is the relation. We can connect these two coordinates using this matrix, and that matrix is denoted by PBC. Okay, and what is PBC? PBC contains the coordinate of u1 with respect to c. That is the first column of PBC. Okay, PBC means matrix with respect to B and C, or matrix from B to C. Okay, and its first column is coordinate of u1 with respect to C. What is u1? u1 is the first basis element in B. Okay, u1 is here, right? Then you find the coordinate of u1 with respect to C. That's all. That is the first column. Then next we choose u2. u2 from this, u2 is the second element from B. Then find the coordinate of u2 with respect to C. That is our second column. Clear? Similarly, you can find un with respect to C. Then this matrix is called transition matrix from B to C. That means if you know this matrix and coordinate of v with respect to b, then if you know these two, then you can find the coordinate of you can find the coordinate of v with respect to c. That's why this is called a transition matrix from b to c, right? If you know the coordinate of v with respect to b and this matrix, then you can generate the coordinate of v with respect to c. That's why this is called a transition matrix from b to c. Clear? Okay, similarly you can define PCB. What is PCB? Transition matrix from C to B. That means if you know the coordinate of vector with respect to C, then by taking the product of these two matrices, that gives the coordinate of V with respect to B. Okay, so we have two transition matrices corresponding to two bases. One is PBC and other is PCB. Okay, PCB stands for C to B. If you know the coordinate of C, then you can construct coordinate of B using this matrix. And similarly PBC. Okay, let's see an example. Find the transition matrix from the basis B is equal to 1, 0. These are standard basis. To C equal to 1, 1 minus 1, 1 in R square. And verify the above result for the coordinate representation of 3, 2. Okay. Okay, how to find the transition matrix from B to C? You have to find the coordinate of u1 with respect to C. What is u1? ui's are the members of B. So we take the first element from B, that is u1, then find the coordinate of u1 with respect to second basis. Okay, that's our first column. Similarly, you can find all the columns. Okay, so our first basis is B. We have to find B to C. So we choose our first base as this one. So this is our U1 and U2, and this is our V1 and V2. Okay, so our first column of the transition matrix is nothing. It is the coordinate of U1 with respect to C. So how to find the coordinate of U1 with respect to C? First you have to express U1 in terms of C, then take the coefficients. Make it a column. That is our coordinate. Okay. Okay, that means 1 0 equal to C1 times 1 1 plus C2 times minus 1 1, and you can expand this one, that like C1 minus C2, and second one is C1 plus C2. So you can compare the coordinates. So C1 minus C2 equal to 1 and C1 plus C2 equal to 0. Then you can easily solve the system. Okay, by solving the system we have C1 equal to 1 by 2 and C2 equal to minus 1 by 2, right? Okay, so what is the first column of PBC? That is coordinate. What is the coordinate? Okay, what is the coordinate of U1 with respect to C? You simply arrange they are in a column. So this is the coordinate of U1 with respect to C. So our first column is 1 by 2 minus 1 by 2. Clear? Similarly, we have to find the second column. Second column. How to find? We have to find coordinate of U2, the second element from B, that is coordinate of U2 with respect to C. How to find? A similar argument. First of all, you have to express U2 in terms of these two base elements, then find the coefficients, then make it a column. So second element U2 is 0 1. So 0 1 equal to D1 into first base element plus D2 into second one. Compare the coordinates. So 0 equal to D1 minus D2 and 1 equal to D1 plus D2. You can solve this. So D1 equal to 1 by 2 and D2 equal to 1 by 2. So now you can directly write the second column. What is second column? The coordinate is 1 by 2, 1 by 2. So this is the transition matrix from B to C. Clear? Okay, next we have to verify this result. That means we have to check whether what is P, B, C into V with respect to B. We have to check whether is it equal to V with respect to C. Okay, so next you have to compute this matrix, the product. Okay, already we know that the coordinate of V with respect to B is 3 2, and coordinate of V with respect to C is 5 by 2 minus 1 by 2. Okay, so they are the coordinates. So next we are going to simply compute this product. Okay, our PBC is this matrix into coordinate of V with respect to B, that is 3 2. Then you take the product. What is this product? 1 by 2 into 3 plus 1 by 2 into 2. That is nothing, 5 by 2, right? And next one is minus 1 by 2 into 3 plus 1 by 2 into 2. That is nothing, minus 1 by 2. This is same as our B with respect to C. This is okay. We consider this product and the product equal to matrix. Okay, so we verify the result. This result. Okay, second problem. Find the transition matrix from C to B. The same question, only difference is we have to find the reverse transition matrix. In previous problem, we solved transition matrix from B to C. Here we have to find the transition from C to B. How? Okay, the only difference is instead of B, we have to use C. That's all. Okay, so here we take C and here we take B. So we take the first element from C, then represent, then find the coordinate of U1 with respect to B. That's all. Okay. Similarly, we have to take the second element from C, then represent U2 in terms of B. That are the columns of the transition matrix. Okay. Okay, our first element is 1 1. You can write 1 1 in terms of B, that is C1 into 1 0 plus C2 into 0 1. It is clear that C1 equal to 1 and C2 equal to 1. So what is our first column of PCB? 1 1, right? Similarly, next we have to represent minus 1 1 in terms of our basis element. You take some d1 into 1 0 plus some d2 into 0 1. And what is d1 and d2? It's clear that d1 is minus 1 and d2 is 1. Okay, so this is the transition matrix from C to B. that means what? That means if you know the transition matrix of now, suppose if you know the coordinate of V with respect to C, then we can find coordinate of V with respect to B. How? By taking the product PCB into this one, and PCB is known. So what is this? 1 minus 1 1 1 into, we have next we have to verify the relation of coordinate. Okay, we consider PCB into coordinate with respect to C. What is coordinate with respect to C for this vector? That is 5 by 2 minus 1 by 2. And what about this product? This is nothing, 3 2. Okay, that is exactly our V with respect to B. So we are starting from PCB into VC, that is equal to coordinate of V with respect to B. Okay, so this is the relation between this transition matrix and coordinates. Okay, and another interesting property of this transition matrices are corresponding to a pair of two bases. We have two transition matrix. One is from B to C, other is from C to B. Okay, then is there any property? Does there exist any property between these two matrices? Yes, you simply consider the product. What about PCB into PCB? You take the product of these two matrices in any order. What about that? That is equal to I, identity matrix. Okay, this is, oh sorry, this is one is PCB, other is PBC. Sorry, PCB into PBC or PBC into PCB, whatever be, no problem. Whatever be the order, the product of these two matrices is always I. Okay. Okay, that is our next result. The transition matrix from B to C, yes, where both C and D are bases for a vector space, is invertible. That means transition matrix from B to C means, what is the notation? P, B, C, B to C is invertible, and its inverse is the transition matrix from C to B. Clear? That means PCB into PCB equal to I, or you take the inverse of this matrix, that is nothing, that is PCB. That's the meaning. Okay. Okay, consider the next problem. Find the transition matrices. So we have to find two matrices between two bases G and H for P1, and verify the results for the coordinate representations of the polynomial 3t plus 5 with respect to each basis. Okay. So let V is equal to 3t plus 5. Okay, then we can easily find the coordinate of V with respect to G as well as coordinate of V with respect to H. Okay, how to find coordinate of V with respect to G? You take V, what is our V? 3t plus 5, that is equal to C1 times with respect to G. G means they are the base elements. So C1 times T plus 1 plus some C2 times T minus 1. Then we have two equations and two unknowns C1 and C2. You can solve C1 and C2. Then that C1 and C2 is nothing. C1 equal to 4 and C2 equal to minus 1. Similarly, you can find the coordinate of 3t plus 5 with respect to H. That is 12 minus 7. Okay. Okay, next we have to find PGH. Okay, how to find the first column of PGH? Take the first element from G, that is T plus 1. Then express T plus 1 in terms of elements from H. Okay, that means some C1 times 2T plus 1 plus C2 times 3T plus 1. Okay, then solve for C1 and C2. Then you have two equations in C1 and C2. You can solve for C1 and C2. What is C1 and C2? Okay, by solving these equations, we have C1 equal to 2 and C2 equal to minus 1. So our first column is 2 minus 1. Right. Similarly, you can find the second column. How? Take the second element, that is T minus 1. And write T minus 1 in terms of basis elements in H. So that is 2T plus 1 plus some D2 into 3T plus 1. Then you have two equations. Okay, by comparing the coefficients of T, this become 1 equal to 2d1 plus 3d2, and the constant time is minus 1, that is equal to d1 plus d2. Then you can solve for this system of equation, then d1 equal to 4 and d2 equal to minus 3, right? Sorry, this is minus 4 and plus 3. Okay. Anyway, you can solve this system. So what is our second column? Second column is given by minus 4 and 3. So this is the transition matrix from G to H. Okay. Yes, PGH is equal to 2 minus 1 minus 4 3. Then how to find PHG? Either you can use the same rule. You take the first element from H, then represent H in terms of G. Then you find the coordinates. That is our first column. Similarly, you can find second column. Or you can find PHG using our previous result. We know that PHG is nothing. It is inverse of PGH. Already we have PGH. So you take the inverse. Okay. So this is nothing. This is the inverse of this matrix. Okay. Okay, next we have to verify above result using the coded representation of 3t plus 5. Already we know the coordinates of 3t plus 5 with respect to g and h. Next we have to check the result. What is our result? We know that pgh into the coordinate of v with respect to g should be coordinate of v with respect to h. And similarly, we have to verify the result phg into coordinate of v with respect to h should be equal to coordinate of v with respect to h. You can easily verify these two results because everything is available. V with respect to g is there, pg with respect to h is there. You can take the product. If you take the product of these two matrices, that gives this one. Okay. Similarly, next one phg into vh. That means you take the product of this matrix into this matrix. That gives this one. Okay, that is a verification. So you can easily verify everything. Okay, so all of you please verify these two. Okay, this is your homework. Thank you.